So hopefully everyone can see that. We're gonna start with descriptives, then we're gonna move forward to the probability, then standard normal distribution, and then Poisson. Is that all right with everyone? Yes, then I assume that it's fine. So the first exercise is about the exchange rates. It's pretty simple, and we've done this during the first tutor session. Sorry, do you hear me well? Because I hear like echo sound. Can you just type in the chat if everyone is hearing me well? Okay, great. Thank you so much. So the exercise is that we have the daily euro to USD exchange rates converting, and they are as follows. And then we have daily US dollars to Japanese exchange rates that are as follows. So I will try to annotate or do it like a whiteboard. So we have our x1 values, and then we want to calculate the deviation about the mean. So so now you should see like a whiteboard. So the deviation about the mean should be x1 minus x. And then what we want to have the squared deviation about the mean. And we're gonna start with the values. So to calculate the variance, you need to have the squared deviation about the mean. So our values were as follows. We will start with the USD to Japanese. So if you want to open the exercise in the book, it's the exercise 2.20. If you want to look it up in the book, or if you want to look at the instructions once again. So the sum of it will be then 771.37, and the mean will be simply 1, 2, 3, 4. We have seven observation numbers. Yes, I forgot the last one, 111. So the sum of it will be this, 771.37. And then you take this 771.37 and divide it by the number of observations, so 7. And then you should get that the mean will be 110.2. So then the deviation from the mean will be 109.95 minus 110.2. So then you do it the same with all the values. And then to calculate the squared deviation from the mean, then you take this 109.95 minus 110.2, and then you take it and square it. And then you sum every squared deviation. You sum it, you add like all the different values from every row. And then you should get that the standard deviation will be, or first you calculate the variance, and the variance will be with then, if you sum all the squared deviation about the mean, so the variance will be the sum of all the squared deviation about the mean divided by n minus 1. So this will be the sample variance, so S2. And this should give you the number 0.452285. And then the standard deviation will be simply the square root of the variance. So it will be simply the square root of this number of 0.452285, which will equal 0.175. It will be approximately this number. So when you convert the euro to USD, when you want to calculate the mean and then the variance and the exchange rate, and then the standard deviation, sample standard deviation, you simply follow the same strategy. You calculate x1, x, the sum of all the x, and then the deviation about the mean. And then you calculate the square deviation about the mean. And then you sum it, so you get this. So this is your procedure. So then the sample mean should be all the observations summed, divided by the number of observations. And this should give you, in this exercise, 1 point, approximately 1.1332, and then you calculate the deviation. So you take the mean minus, you take the observation minus the mean, and you sum it, all the observation numbers, and you square it and divide it by n minus 1. So all the number of observations. So in this exercise 7, so 7 minus 1, which will equal to 6. And then your standard, your variance will be very, very small. And then the standard deviation. So standard deviation will be the square root of the variance, which will equal to 0.00499. So in this exercise, your final solution should be that euro to USD, the mean will be 1.1332. Then the variance will be very, very small, approximately 0.00. And then the standard deviation will be the square root of the variance, so it will equal 0.00 approximately 5. And then the second conversion is USD to Japanese. And then your mean should be 111 approximately. Then variance will be 0.45. And the standard deviation should be the square root of 0.45, which will equal approximately 0.175. Do you have any questions, or are you following? Okay, if you don't have any questions, then we continue with the presentation. So now we move into the probability postulates. And this is from your lecture notes. So now you know that the complement of the event is 1 minus the event. The union of two events is equal to the probability of these two separate events minus the probability of the event plus probability of the other event minus the intersection. And so the probability of event A given event B will equal to the two events intersection minus the probability of the event B. And A and B are statistically independent if and only if the intersection of the two events is equal to probability of A times probability of the other event. I'm sorry, I just need to turn off my... So yes, the next exercise is about the calculating probabilities. A survey carried out for a supermarket classified customers according to whether their visits to the store are frequent or infrequent, and whether they often, sometimes, or never purchase generic products. The accompanying table gives the proportions of people served in each of the 6 joint classifications. And so we know that in this exercise, the frequency of visit can be often, sometimes, or never. And the first question will be then, what is the probability that a customer both is a frequent shopper? Can you all hear me? Sorry, because it looks like you don't hear me. Can you write? Okay, you can hear. That's good. I received a suggestion to do sampling confidence and statistical inference instead. I received the instructions to go through this type of questions, not sampling, not confidence intervals. But we can do it on Friday if that's okay with you. Would that be okay? Okay, sure, great. So yes, so the first question is, what is the probability that a customer who never buys generic products visits the store frequently? So here we know that the intersection between the frequent and never visiting, being a frequent customer, never buying generic products is 0.16. And then to calculate the probability of never buying a product, you simply sum up the probabilities of never buying the product and being frequent and infrequent customer. Sorry, I'm just connected to my iPad, and I think that was not a good idea because I have some problems with the voice. Yes, now I turned it off, so now it should be fine. So then the probability of being a frequent customer conditioned on never buying generic products will be the intersection between being frequent customer and never buying generic products divided by the probability of never buying generic products. And this is a reminder from your class that if A and B are independent events, then the probability of A happening and the probability of B happening will be the multiplication of probabilities of the two events. So then the next question will be then, are the events never buying generic products and visits the store frequently independent? So my solution to this will be then to take the probability of never buying the generic products times probability of being a frequent customer, and it will be 0.18. And the intersection between never buying generic products and being a probability of being a frequent customer will be then 0.16. And therefore the events are not independent because the intersection of the two events is, and the multiplication of the two events is not equal. So therefore they are not independent since the rule is not fulfilled. And the next question, are the events often buying generic products and visits the store infrequently independent? So can someone explain to me how they would solve this exercise? You know that two events, in order to make them independent, they need to, their intersection must equal the intersection of the probability of the two separate events. So can someone just quickly, briefly brief me about how to solve this exercise? Is anyone willing to explain to it, just briefly, how to solve this type of exercises? Okay, then you simply follow the same procedure as previously. You first need to calculate the probability of one event, and then the probability of often visiting a shop will be then for all these customers independently, if they are frequent or infrequent. Then you take this number and this, and you receive 0.22. Then the probability of being an infrequent customer, then it's simply the sum of all these events of being infrequent. So now you know the probability of these two separate events, and if you multiply them, then you know that it will equal to 0.0462. And since the intersection of these two events, so intersection, by this I mean the probability of often purchasing generic products, and the intersection of being infrequent, then you need to look at this and then at this. So it will be 0.08. So the intersection between being purchasing generic products often and being an infrequent customer is equal to 0.08. And since 0.08 and 0.22 is not the same, then therefore the events are not independent. And so now, what is the probability that a customer never buys generic products? Then it's simply calculation of, independently of if the customer is frequent or infrequent, you calculate the probability of never purchasing generic products. So simply you take this number. Oh, sorry. Take this number and this number, and you receive this number. So this will be then the probability of, sorry. So then the probability of never buying generic products will equal this number plus this number, which is equal to 0.25. What is the probability that a customer either frequently visits the store or never buys generic products, or both? So then you want to calculate the intersection between being a frequent visitor, frequent shopper, and never buying generic products. So you simply take this number, and sum up with this number and this number, because then you're a frequent, you're both a frequent customer and never buying generic products. Because here, to calculate the probability that a customer is both a frequent visitor and buys generic products, you need the whole union of these two events. So if you have two circles or two events, and one is being a frequent customer, and the other event is never buying generic products, So in this case, you want the whole union of it, because you want to cover all the events when the customer is a frequent visitor and never buys generic products. So you want to cover the whole space of these two events. Yes, now we move to the next exercise, where a corporation regularly takes deliveries of a particular sensitive part from 3 subcontractors. It found that the proportion of parts that are good or defective from the total received were as shown in the following table. So you have 3 different subcontractors, and there are different probabilities of having rather a good product or a defective product or defective parts. And if a part is chosen randomly from all of those received, what is a probability that it is defective? So here I summed up all the probabilities of having good product or having a defective product, and in total you have 100%, and so the probability of having a good product will be then 90%, and the probability of having a defective product, then it will be 10%. So the probability that the product is defective will be then 10%. If a part is chosen randomly from all those received, what is the probability that it is from subcontractor B? So then I summed up simply all the probabilities. So the probability that the product is from subcontractor A, it will be this probability that it is from subcontractor A and that the part is good, plus that the part is from subcontractor A and that it is defective. So the sum of all these probabilities will sum up to this, and then the probability that it is from subcontractor B then will be 35%. So then the probability that it is from subcontractor B will be then the probability that it is good or defective from subcontractor B, because it's chosen randomly. And then what is the probability that a part from subcontractor B is defective? Then we need to have the conditional probabilities. So then the conditional probability of having a defective product conditioned on, given that the product is from subcontractor B, will then be, we will use this formula presented in the beginning, where you take that the probability of event given another event will equal the probability of this having a defective product, this first event, divided by the probability of the other event. So in this case, this probability that the product is defective, given that the product is from subcontractor B, will then be equal to, so this PD given B, I use this formula PD divided by PB. And you should get that it's equal to 1 divided by 7. So now we move to the next exercise, to next slide. So yes, next exercise is there quality of a part independent of the source of supply? So here we want to see if the two different events are independent of each other. So then if they are independent of each other, you need to calculate, you need to check this initial conditions if the intersection of the two events is equal to the multiplication of the two events. So if the probability of the two events is independent, then probability of A times probability of D should equal the intersection of these two events. And we know that the intersection of these two events will be 0.02, and multiplication, because the probability of having a product from subcontractor A, then it's 0.29. And the probability of having a defective product, which we previously calculated, is 10%. So the multiplication of these two events will be then 0.029, which is not equal to the intersection. Therefore, they are not independent. So there is a dependence of the source of supply, the subcontractor, and the quality of the part, the probability that it will be rather good or that it will be defective. What do you think about the speed? Can you unmute yourself, and do you think it's going too fast or too slowly? What do you think? Should I take it more easy and go like more into the details? Or is it fine? Are you fine with the speed?
Well, those a bit are easier things, so we can go a bit faster on those, and maybe have a bit more on a more, when it's a lot of things asked, like more complex exercises.
Okay, so you want to have it faster now?
A bit, yeah, on these, because this is something like we did right before, okay. Like previous exercise, it's kind of over and over again the same thing.
Okay, great, thanks. Okay, great.
Sorry, I didn't mean to be rude.
No, I understand. Thank you so much. So, in terms of quality, which of the three subcontractors is most reliable? Then you want to calculate the probability of the event that the quality is good, given that you have it from a specific subcontractor. So then you follow exactly the same procedure. You take the probability of that the product is good. So here it is, and divided by the probability that it's from a specific subcontractor. So here, for instance, you take the probability that it's good and it's from subcontractor A, divided by the probability that it's from subcontractor A. And you see that the probability that the product is good given a specific subcontractor is highest for subcontractor A. So therefore here you can answer that subcontractor A is the most reliable, since the probability that the product will be good is highest if you buy it from subcontractor A. You're free to ask any questions if you have any. So here in this exercise, Dean has found that 62% of entering freshmen and 72% 78% of community college transfers eventually graduate. So of all entering students, 73% are entering freshmen, and the remainder are community college transfers. So here I defined the two events. The event A will be then that the student will graduate, and event B will be that the student is an entering freshman. So what is the probability that a randomly chosen entering student is an entering freshman who will eventually graduate? Then I take the intersection of these two events. It's both a randomly chosen entering student event, this event B, and it's the probability that the student will graduate. So it's the intersection between the two events will be the multiplication of the two events. So it will be approximately 45%. And the second question is find the probability that a randomly chosen entering student will eventually graduate. So here we want the probability of event A. And so here we take, in this specific exercise we have stated that 72% of entering freshmen will graduate. So 72 of this remaining 27%, and 78% of this entering students, that are 73% of total students. So then you take the probability of graduating as entering students, that is entering freshmen, and plus the probability of being the remainder of the community college transfer times the probability of graduating. And you should receive approximately 63.6%. And then the next exercise will be, what is the probability that a randomly chosen entering student either is an entering freshman or will eventually graduate, or both? So in this case, you want to have the union of these two events, the union of being a randomly chosen entering student, that is an entering freshman, and the other event that is that the student will eventually graduate. And you receive this formula in the beginning, in the introduction, that the union is equal to the separate two events plus the intersection, minus the intersection, because you don't want to double count the intersection. So if you have the two events, I'm just gonna draw it for you. So you have two events, event A and event B. Event B, to take the union, the entire surface, you take this event plus this event. And since you take the intersection two times, you want to exclude it to receive the union, the whole area covered. So then now we move to the next exercise. And here you have that an insurance company estimated that 30% of all automobile accidents were partly caused by weather conditions, and that 20% of all automobile accidents involved bodily injury. Further, if the accident involves bodily injury, then in 40% of the cases it was partly caused by weather conditions. And the first exercise is, what is the probability that a randomly chosen accident both was partly caused by weather conditions and involved in bodily injury? Anyone has any suggestion on how to solve this? So if you don't have any suggestions, then you know that the probability that a randomly chosen accident both was partly caused by weather conditions and involved bodily injury, then we want the intersection between the accident that was partly caused by weather conditions and accident involved bodily injury. You want the intersection of these two events. And you have in the introduction, you had this formula that the intersection of two events is equal to the probability of certain event given the probability of the other event times the probability of the other event. And here in this exercise, it was stated that you had this probability that 30% of all automobile accidents were caused by weather conditions, and 20% of all of them involved bodily injury. So now you know that the probability of the event being caused by weather conditions is 30%. The probability of it involving bodily injury is 20%, and the intersection will be then. And here you have also stated that given that it involved bodily injury, then it was caused by weather conditions, and it was the 40% of the events that was that it involved bodily injury given weather conditions. So then you simply follow this formula and you receive that 8% of the events caused by weather conditions involved bodily injury. And now I want you to interact with me a bit. So are the events partly caused by weather conditions and involve bodily injury independent? How would you think about it? So you want to, as previously, you want to follow the same strategy. You want to see if the intersection of these two events, event A and event B, is equal to the multiplication of these two separate events. If the probability A times probability of B is equal to the intersection of probability of event A and probability of event B. So the multiplication of these two events will be then 6%. And you know that the intersection from the previous previous exercise, you know that it was 8%. So here the multiplication is 6%, instead 0.06. Therefore, the events are not independent since the intersection is not equal to the multiplication of these two events. And hence the events are not independent. So it's the same, basically the same structure as previously. So the next exercise is if a randomly chosen accident was partly caused by weather conditions, what is the probability that it involved bodily and injury? So now we want to have the opposite of what we've done previously. Given that it's caused by weather conditions, what is the probability that it involved bodily injury? So here you follow the rule that a probability of given event, of a specific event given the probability of the other event, is equal to the intersection between these two events times the probability of this specific event. And we knew that the intersection between event A and B was 8%, and the probability that it involved bodily injury was 30%. So then you calculate the multiplication of this, and you receive that 20% is the probability that it involves bodily injury, given that the accident was caused by weather conditions. So what is the probability that the randomly chosen accident both was not partly caused by weather conditions and did not involve bodily injury? Then you want to take the complement of these two events. So the complement is everything that is not in this event. So if this is our two events, if these are our two events, then everything that is outside of this space is the complement of these two events. So here we want to calculate the complement. So everything that wasn't partly caused by weather conditions and did not involve bodily injury. So to calculate the complement, you take the 100% 1 minus these two events, the union of these two events. And here to calculate the union, you use this formula that union is equal to probability of a specific event plus probability of this other event minus the intersection of these two events. And you should end up with having 58%. This will be the probability that a randomly chosen accident was not partly caused by weather conditions and did not involve bodily injury. So now we're gonna take a break, 5 minutes break, if that's fine with you. And we're gonna move forward through standard normal distribution and Poisson exercises, if that's fine. So during the break, I have a math puzzle for you that I want you to solve. I'm just gonna present it to you. You have 5 minutes. So, and the math puzzle is that you have a triangle. If you don't want to participate, you can take your break, your 5 minutes break. But the puzzle is that you have a triangle and it has equal arms. And the angle between the arms, it will be then 30%. And the area of this triangle will be then x plus 3 divided by 2. And I want you to calculate the different arms of the triangle. So if I'm gonna draw this math exercise, you have a triangle. And here, this angle will be 30%. So this angle will be 30%. And the area of the triangle will be then x plus 3 divided by 2. And I want you to calculate the difference. Like if you know that the angle between in the triangle is 30%, then what will be the 2 different arms of this triangle? Do you understand the question? It's just for fun. If you don't want to solve this exercise, then it's fine. It's just to refresh the mathematic skills. So the angle between the 2 different arms will be then 30%. Anyone has any solution to this math puzzle? Okay, you can think about this math puzzle and it's just for fun. You don't need to solve this if you don't want to. So we can move forward now. Or yeah, you have 1 more minute. Or yeah, now we can start. You had a 5 minutes break. You can think about it, this math puzzle, and I can go through the solution after we've done all the exercises, if you are interested. So just to repeat, the math puzzle was that we have a triangle, and you want to calculate like the 2 arms, the 2 arms of the triangle. The angle here is 30%, and the area is equal to this. Yes. So now we're gonna go through the standard normal distribution, and you know that in the standard normal distribution you have a bell-shaped graph, and in the bell-shaped graph the mean is equal to 0, standard deviation is equal to 1, and z-score corresponds to the area under graph. And you can standardize the normal distribution using this given formula, x minus mean divided by standard deviation, where the z-score is corresponding value of the original variable x. So here we have the first example. We have a bone density reading between -1 and -2.5. That indicates that the subject has osteopenia, and we want to find the probability that bone density will be then between -1 and between -2.5. So anyone has any suggestion how to solve this exercise? If we know that the critical value z is equal to the area under the graph, how would you solve this exercise? So yeah, I'm gonna draw it for you. We want to have the difference between the two. We want to have the difference between the two critical values, the two areas. So in this exercise, we have this area, and we know here that here z is equal to -1, and it's equal to, this area is equal to 0.1587. It was stated first, and then you know that here where that critical value was -2.5, it was equal to 0.0062. So you want to calculate the difference between these two. So you want to have this area that is not included in the first one, and it's not included in the second one. So then this area will equal the difference between these two, and it will equal 0.1525. So this was this area minus this area, 0.0062. And so now we move to the next one. Next example. Example 2. Suppose that IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. A person with an IQ score of 145 is considered a genius. Does this empirical rule support this statement? So how would you go about it? It's always a good idea to draw. Here we solve it by, we know just to repeat, we know that the mean is 100 and standard deviation is 15, and the person is IQ score is 145, and we want to check if it's really rare to have IQ score of 145 in the population. So we want to check if the empirical, the reality supports this statement. So here I'm gonna share with you my whiteboard. So the best idea with this type of exercises is to draw. So we draw a bell curve shaped. And we know that if it's a normal distribution, then the mean U will be 0. In this case, 100. In this case, we have stated that the mean is 100. And like in the standard normal distribution, it's 0. But here we don't have a standard, we have specific condition stated. We have a condition stated that the mean is 100, and we know that in this case we have a standard deviation of 15. So to calculate non-standard normal distribution, we use this formula that I presented you in the beginning. So we calculate the deviation from the mean divided by the standard deviation. So x minus the mean, the average, divided by the standard deviation. And here we know that it will equal 145 minus 100 divided by 15. So it's equal to 3. So this critical value in this example will be 3. So what we calculate is this area. And we know that z here will equal to 3. So we want to calculate the area in extreme. And if we like compute it in R or look at the tables, we know that if the critical value 3 is 3, then this distance will be for the critical value equal to 3, then this distance will be 0.4987. And so then the probability that the IQ score is greater than 145 then will be this area. So we want to calculate this area in extreme, which will equal to this area, which is 0.5 minus this number. So 0.5 minus 0.4987, which will equal to 0.0013, which will equal to 0.113%. So the probability that a person is a genius or has IQ above 145 will be then 0.13%. So this rule to have that if a person has an IQ above 145, then it's in line with the empirical data, because 0.13% of the population is very rare. So this person having an IQ above 145 is a very rare person. So you can say that this person is a genius. So yes, now we move to next exercise. Here you know that an author receives from a publisher a contract according to which she's to be paid a fixed sum of $10,000 plus $1.5 for each copy of her book sold. Her uncertainty about total sales of the book can be represented by a random variable with mean of 30,000 and standard deviation of 8,000. Find the mean and standard deviation of total payments she will receive. Let the random variable x represent total sales of the book, and let the random variable y represent the payments to the author. So we want to find the mean, and so we take the value that she's told to be paid fixed plus this amount she's going to be paid for every copy times the mean that she is sold, and we calculated then that the mean of the the mean of the total payments will be then $55,000. And then the standard deviation will equal to the amount for every copy times the standard deviation of all the sales. And then it will be the standard deviation of the amount sold will be then $12,000. Next exercise. An investment portfolio contains stocks of large number of corporations. Over the last year, the rates of return on these corporate stocks follow the normal distribution with a mean of 13% and standard deviation of 6.4%. So for what proportion of this corporation was the rate of return higher than 19%? So here you want to calculate the probability that X is equal to X is greater than 90%. So you calculate the probability that the critical value is equal to 90% minus the mean divided by the standard deviation, and then you end up the value in the parentheses then will be 0.7432. So this number will equal 0. It doesn't look good, but 7432, and this number in the parentheses. So then you want to have probability that the critical value will exceed 0.7432, and it's the same as taking the complement of this event. So it will equal 1 minus 0.7704, which is approximately 26%. So the proportion of this corporation that had return higher than 90% was 26%. Sorry, it doesn't look good, but you understand the concept. And for what, next question is for what, just gonna delete it, for what proportion of these corporations was the rate of return between 10% and 20%? And you follow the same strategy. You want to find the probability that X was between 10% and 20%. So it's in contrast to this is like one tail, and this is a one tail test, and here you have two tail test. So you follow the same method, but here you have two tails, the upper bound and the lower bound and the upper bound, and you calculate this by taking that this so this can be this can be rewritten So my annotate function is not really working, but now, yeah. Now you can rewrite it in terms of that P and Z lower than 0.878 minus P critical value lower than minus 0.473, which will then equal to so if you look at the table of the value for critical value of 0.878, you receive this value. Minus you can rewrite it like this, 0.463, and then you look up the second critical value, or you can calculate it with R. And you should end up that the proportion will be then approximately 50% for this exercise. Look back to mouse on this annotate function. Yes. Yes, and sorry, I skipped this this one. The proportion of these corporations that had negative rate of return, then you want to calculate all the value of x that is lower than 0, since x is the rate of return, and then you follow the same procedure. You take that 0, the critical value is lower than the x minus the mean divided by the standard deviation, and then you calculate it with R or look at the table, and your final value should be approximately 0.0344. And now we move to the last chapter, which is Poisson and Poisson distribution. Here you have a random variable that is characterized as the number of occurrences of a certain event in a given continuous interval, and you assume that the probability of the occurrence of an event is constant for all subintervals, and there can be no more than one occurrence in each subinterval, and the occurrences, the events are independent, so one event does not influence the probability of the event in another interval. So to calculate the Poisson distribution, you use the following formula. You have the probability of x successes over a given time or space, given lambda, and lambda is the expected number of successes per time or space unit. And then lambda is equal to the average, and the standard deviation is also equal to lambda. So here we have, in this exercise, we have customers that arrive at a busy checkout, and they counter at an average rate of 3 per minute if the distribution of arrivals is Poisson, find the probability that in any given minute there will be 2 or fewer arrivals. So what will be the lambda here? Anyone has any idea? So the lambda here, oh sorry, the lambda here, my annotative function is not really working as it should be. Here, lambda, it's equal to 3, and then x will equal to 2. And therefore, we had this formula that we're going to use. So the probability of the x being 2 will then equal, use this formula. So here we use this formula, and we just plug lambda and x stated in the exercise. So minus e to the power of minus 3 divided by this, and 3 to the power of 2. We use this equation. And so using this equation for different values of x, so here for instance, we used the same plugging in that lambda is equal to 3 and 3 to the power of 0. We plug it in and use this exercise, this equation, and we receive this number. And then we take this number and add it to the next one here. And so here we plug in that x is equal to 0. So here will be e to the power of 3, and then 3 to the power of 1 divided by 1. And we sum it up with this number. And so it's cumulative distribution function, so you sum it up. So we use again this equation, and we just use different values for x. And then the question is, find the probability that in any given minute, there will be 2 or fewer arrivals. So the probability that it will be 2 or fewer arrivals, then we take this number, and this number, so all the numbers before 2 lower than 2, and it will equal this, since it will be the cumulative probabilities, and we already adjust because we sum them up. Here it's not only this one, this equation. Oh, sorry. Minus 3 times 3 to the power of 2 divided by 2. It's not only this one, it's not only the probability that x is equal to 0, but it's cumulative probability, so we already included this one and this one in this number. So this will be the answer to this exercise. Any questions? Okay, then we move forward to the next exercise. Records indicate that on average, 3.2 breakdowns per day occur on an urban highway during the morning rush hour. Assume that the distribution is Poisson. Find the probability that on any given day, there will be fewer than 2 breakdowns on this highway during the morning rush hour. So here we want to have the cumulative probability distribution. And we use Poisson because we know that the mean is 3.2 breakdowns, and the standard deviation. No, we don't need the standard deviation. We want the probability that x is equal or lower than 2, and sorry, it's lower than 2. So it will be the same as the probability that it will be lower than 2 will be the same as being the same or lower than 1. And we use the same function, the function that I presented you in the beginning, this one. That e to the power of minus lambda times lambda to the power of x divided by x. Sorry, you might not see it as well. I mean this function. So here I used this function. I calculated the cumulative distribution for this exercise. So I just simply plugged in different x values, used this formula, and I received this cumulative distribution function. So the probability that x will be 1 or lower than 1 is then equal to this number here. And then we have the B, and the B question is the B question is find the probability that on any given day there will be fewer than no, sorry. The question was find the probability that it will be more than 4 breakdowns. It will be more than 4 breakdowns. So we take the whole sample space, which is equal 1 to 1, minus the probability that x is equal to or lower than 4. So everything that is greater than 4 is equal to, since you know that the sum of all these events should be equal to 1, and the sample space should be 1, we take 1 minus the probability that x is equal to or lower than 4. And in this cumulative distribution function, you can see that x is equal to or lower than 4 for this value here. So the answer is approximately 22%. And we move into the next exercise. A contractor estimates the probabilities for the number of days required to complete a certain type of construction project as follows. So we have the times, the days, and the probability that the project will be completed. So the shorter amount of time, the lower the probability, but also after the third day, the probability will decrease, so the highest probability is at day 3. What is the probability that a randomly chosen project will take less than 3 days to complete? So we define our x as, it's in Swedish, but it's the number of days, antal dagar, the number of days. So then the question will be, what is the probability that the number of days is lower than 3? And it's the same thing as being equal or lower than 2. Sorry if there is a noise in the background. It's my cat that is sleeping and making strange sounds. Anyways, here, so you use the function and the probability, you sum up the probability that the number of days is equal to 1 and the sum that the number of days is equal to 2. And in the exercise it was stated here that this probability that the project will be completed after 1 day is 5%, and after 2 days it's 20%. So you sum them up and you receive that the probability that the project will take less than 3 days to complete is 25%. Find the expected time to complete a project. So here we know we sum up the expected value, expected time, the expected number of days by taking the probability of completing the project during a specific time, and you sum them all up. So I take, in this exercise, I take 1 times 0.05 plus 2 times 0.2 plus 3 times 0.35 plus 4 times 0.30 plus 5 times 0.10. And the expected time to complete this project will be then 3.2. And now the next exercise is to find the standard deviation of time required to complete a specific project. So we know we have this formula that standard deviation is equal to a specific probability of completing the project times the number of days to the square. So here I take all these probabilities, multiply with the number of days to the square, square number of days plus probability times square number of days, and I sum them all up, and the sum will be then 11.3, and the variance in this case will be taking the expected value, the squared expected value, minus the squared mean that we calculated in previous exercise. So here we calculated the squared expected value, and variance we calculate by taking the squared expected value minus squared mean. And after calculating this, we have the variance, and to compute the standard deviation, we need to simply take the square root of the variance, and we will end up with the value 1.03. So the standard deviation of time is approximately 1 day. It's approximately 1 day of the project. So the contractor's project cost is made up of 2 parts, of a fixed cost of 20,000 plus, in Swedish it's called rörlig. It's like, it's you get paid $20,000 for each day to complete the project, and the task here is to find the mean and standard deviation of total project cost. So why I wrote it in Swedish, it's kostnad. It's the total project cost. Is this the variable that we seek, and it's calculated by taking the 20,000 of fixed cost plus 2,000 for each day. And so the expected value of total project cost will be then, we simply take the expected value of 20,000 plus 2,000 times expected value, and we calculated the expected value in the first part of the question, and the expected value is here. Find the expected time to complete the project. It was 3.2, so we plug it in here and take the expected time of the complete will be then 3.2. So the expected cost will be then, considering that the expected time is 3.2, it will be then 26,400 kronor. And we calculated it by plugging in the expected number of days that we expect that will take to complete the project. And now we want to find the standard deviation of total project cost, and we use the same formula as in previous exercise. So we take the variance of the fixed cost and the variance of the cost of each day, and we know that the variance of that fixed cost will be then the 0, and then so the variance of the cost per day will then be 4,242,000. And the variance of x we calculated here, and that it's equal to 1.06. So we take we plug it in here, 2,000 to this is not right. I should annotate here. So we plug it in here, 2,000 to the power of 2 times 1.02 that we calculated in the previous exercise. So this one, we plug it in this equation, should be 1.02. And this should equal to 4,242,000. And then the variance will be the square root of the standard deviation. So if the next exercise, if the 3 projects are undertaken, what is the probability that at least 2 of them will take at least 4 days to complete, assuming independence of individual project completion times? And so here we seek for the probability that at least 2 projects will be completed during 4 days, and the events will be assumed to be independent. And so we define W as the number of projects that will take sorry, I'm not sure why it closed. I will share with you my screen again.
Yeah.
Here. Here, you should see it now. If not, tell me. So the event W is that, we define it as the number of projects that will take at least 4 days to complete. And since we assume independence of individual project completion times, then we use a binomial distribution. And the conditions the condition stated is that the probability of the 2 events is the same, and there is independence between the individual projects, and the project will take at least 4 days to complete, and we need to find the probability that at least 2 of them will take at least 4 days. So the number of days that will take at least 4 days, it should be equal or less than 2. So therefore, I stated that the small w will be equal to or less than 2, and it's the same as calculating the sum of probabilities for being the projects. W is equal to 2 and plus W is equal to 3. What is the probability that at least 2 of them will take at least 4 days to complete? And we take the binomial distribution. So the x will be then the success number will be rather 2 or 3, and the number of trials will be then the total number of trials will be 3, and calculating it using R or using your calculator, then you should end up with a number that is approximately 35%. And I usually use calculator to calculate these equations, but I know that you use R. And it's the same formula that I use here for binomial distribution that I used during the first session. And so yeah, that was everything I've prepared for today, all the questions. And now I can quickly tell you the solution to the exercise. Okay, I received question if we can go through exam-like questions on Friday. Yes, I will try to do that. I have not received any exam questions, but I can look through my old exams and try to find them, and I will do my best to find as many exam-like questions as possible on Friday. And on Friday we can also go through sampling, confidence intervals, and statistical inference if you want that. Are you fine with that? Do you want to go through sampling? Yeah, okay, then I know what you want, and that's perfect. So we can go through this two different things. And the mathematical puzzle that I showed you during the break, it was simply that you simply take the area function. I can use annotate function to show you. It's not really related to the exam. Can you see the sharing on my screen? Probably it ended just now. So it's not related to the exam or to the course, it's just for fun, the exercise that I presented during the break. So I can simply show you the solution quickly. It's just to refresh the mathematical skills, and it will equal to you know the usual triangle area function, the height times the side, and you take 50% of that, and then it's equal to the area that I presented to you divided by 2, because it was stated in the exercise that it should equal this area, and here you know that you can rewrite this like this. Since you know that this will be your x, you can rewrite it like this: x to the power of 2 divided by 2 is equal to x plus 3, and then x to the power of 2 is equal to 2 times x plus 3 power of 2, and you can rewrite this like this: 2x plus 6x to the power of 2 minus 2x minus 6, and it will equal to 0. And you can then rewrite it like x minus 1 to the power of 2 minus 7, which will equal to 0. And then you can rewrite it to the square root. It will equal the square root of 7x, which will equal to 1 plus minus square root out of 7. So this is the solution. The arms of the triangle will be rather 1 or 7. Yeah, that was a little extra. Thank you so much for today. See you on Friday. Take care.